In this video, I want to explain why this property is true from when the variables are real and all the expressions to calculate the values on the left and right hand side are real. First, I want to explain this for the case of positive integer exponents or counting number exponents, negative integer exponents. Zero is neither positive nor negative, so then we talk about zero exponents, and then rational exponents, and then irrational exponents. Using the definition of exponents with repeating multiplication, 10 cubed is equal to 10 times 10 times 10. We're multiplying 10 to the cell 3 times. Now 10 is equal to 2 times 5, and order does not matter for multiplication. And then again, we use the definition of exponents repeating multiplication. And you can do likewise with variables. Here we have 10 to the negative 3. Now I plan to explain later in the set of videos about the property of negative exponents, and so from that property we can note that 10 to the negative 3 is equal to 1 over 10 cubed. Now 1 is equal to 1 times 1, and we just found out that 10 cubed is equal to 2 cubed times 5 cubed. Now to multiply two fractions, you multiply both the numerators and denominators, and so we sort of undo the multiplying of the fractions, and we get this. And again, we use the property about negative exponents, and we get this. And you can do likewise with variables. What happens if the exponent is 0? Let's say 10 to the 0th power. Well, anything but 0 to the 0th power is equal to 1, as I explained later in the set of videos. And now 1 is equal to 1 times 1. And again, we use the idea that anything but 0 to the 0 is equal to 1. And you can do likewise with variables. 10 to the 2/3, and that cubed. Well, that would be equal to 10 to the 2/3 times 3, because the power to a power is equal to a power times that power, which is a future property in the set of videos. So that would be 10 squared, and that would be 2 times 5, and that squared because 10 is equal to 2 times 5. And we already know that would be 2 squared times 5 squared. This is the property that we're trying to show why it works in this video, and we already shown it works for integer exponents, and 2 is an integer. And now 2 is equal to 2/3 times 3. And now a power times a power is equal to a power of a power. We again use that same property that we used in the beginning of the slide. And again, we use this property that we're trying to explain why it works in this video, and we already covered it for integer exponents, and 3 is an integer. And so that means that 10 to the 2/3 and that cubed is equal to 2 to the 2/3 times 5 to the 2/3 and that cubed. And therefore 10 to the 2/3 equal to 2 to the 2/3 times 5 to the 2/3. And likewise with variables, however, we have a different last step. Because D could be even, all we know from the last step is that the absolute value is equal to the absolute value. That means that removing the absolute values, the left side is equal to either the right side or the negative of the right side. And we want to prove that it is the former for the cases where all the expressions to figure out the left and right hand side are real. And so let's go ahead and do that. If A and B are positive and all the expressions are real, then AB is positive, and so that expression is positive. We can also note that that expression and that expression are also positive, and so that expression is positive. And so as we already know that they are equal with the absolute values, we can now know that they are equal without the absolute values. If C is even and all the expressions are real, that expression would be positive. Those expressions would be positive, and so that expression is positive, because positive times positive is equal to positive. And so as we already know that the absolute values are equal, we can then note that expressions without the absolute values are equal. If A is positive, B is negative, C is odd, and all expressions are real, then AB is negative, because positive times negative is negative, and so that expression is negative. That expression is positive, and that expression is negative, and so that expression is negative. Positive times negative is negative, and so the property holds true. If A is negative, B is positive, C is odd, and all the expressions are real, then AB is negative, and so that expression is negative. That expression is negative, that expression is positive, and so that expression is negative, and so the property holds true. If both are negative, both A and B are negative, C is odd, and all expressions are real, then AB is positive, negative times negative is positive, and so that expression is positive. That expression is negative, and that expression is negative, so that expression is positive, and so the property holds true. If A and or B is 0, and all expressions are real, then AB is 0, and so that expression is 0. That expression and or that expression is 0, and so that expression is 0. And because 0 is equal to 0, we know the property holds true. I just want to show that this property does not work all the time when some of the expressions are not real. For example, -9 times -4 and that to the 1/2 power, is that equal to -9 to the 1/2 power times -4 to the 1/2 power? Well, -9 times -4, that is 36. Negative times negative is positive. -9 to the 1/2 power, that's 3i, which is non-real. -4 to the 1/2 power, that's 2i, which is also non-real. Now 36 to the 1/2 power, that is 6. And 3i times 2i, that is -6. And 6 is not equal to -6. What about irrational exponents? To figure out if this property works or not, we use limits of rational exponents. Now 2 to the 5 and that to the pi power, that is approximately equal to this, so you put this into your calculator. Now 2 cubed times 5 cubed, that's equal to 1,000. And now we get closer and closer and closer to 2 to the pi times 5 to the pi. And that gets closer and closer and closer to 1,385.455 on the right hand side. And so it would make sense for 2 to the pi times 5 to the pi to be equal to parentheses 2 times 5 and a parentheses and that to the pi. Thank you for watching this video. Here is the link for the playlist about the why behind for some properties of exponents.